So a payout annuity is what this account is called. Okay. Right? You know, this is just something in the notes that we saw. This is when you're taking money out on a regular schedule. That is, there's many withdrawals. This is actually the formula we use. It's similar to what we saw before. You know, we have seen this formula in class before, so I'm not going to go through it all again. Again, here, let me just say that PMT, again, is our regular withdrawal, how much we're taking out regularly. P0 is the account in the beginning. You know, how much is in there initially. And we're still assuming that the amount taken out, excuse me, what am I saying? We're assuming that if compounding frequency is not explicitly stated, then the number of compounding periods in a year is how many withdrawals we're making each year. So in other words, unless stated otherwise, as often as we're taking out money each year, that is how often the account is being compounded. All right. So for instance, in this case, if we want to be able to withdraw $1,500 per month for 25 years, right? We know the account earns 6% interest. How much must be in the account initially? Okay, well, P0, right? That's how much is in the account in the beginning. That's what we're looking for. PMT, that's how much money we're taking out regularly, right? In this case, it's how much we're taking out each year, and we're told that's $1,500. Little r, the interest rate, the APR, in decimal form, okay, that's 0.06. Okay, the APR, right, our interest rate, 6%. Here we convert it to a decimal. N, right, that's how often the account is compounding in a year. And that's 12. So I think I might have misspoke. I think I said we're taking out money, we're making one withdrawal per year. Here it's a withdrawal per month. So if I misspoke, I'm sorry. We're taking out monthly withdrawals. So the account's being compounded monthly. And this is going on for 25 years. So using the formula, we plug in, right? We get 1,500, 1 minus 1 plus R, which is 0.06 over 12, raised to the negative n times t, which is negative 12 times 25, and all divided by 0.06 over 12. So we have to calculate this formula. Okay, so again, it's just like before, we have to use order of operations. Work from the innermost parentheses outward. Start inside and work your way outside, so to say. So we have 0.06 over 12, that's 0.005, right? We do that on the bottom as well. 1 plus that, right? That's 1.005. The exponent, right, is negative 300. So we do that raised to the negative 300, and we get this thing. And we do 1 minus that. That turns out to be this. And then we just, multiply, then divide. We get P0 has to be this amount, $232,810. That's what we get here. All right. All right. Other questions on this? So now we'll do the TVM solver. Okay, here, so it's the same problem, of course, but we can use the TVM solver. Now, FV is the future value. That's how much is going to be in the account after all this is done. at the end of the scenario, so to say? Well, theoretically, you want to be able to use up all the money. In theory, okay? So we take FV to be 0 here. You want to use up all the money. You don't want any left. Excuse me, any left in the account. That's better. PMT, that's your monthly withdrawal, right? We're taking money out, so we're getting money. So that's $1,500. I is the interest, written, you leave it as a percent, so 6%. Capital N, it's how often the account is compounded. So it's little n times t, which is, since it's compounded monthly, it's 12. This is going on for 25 years times 25, which is 300. PV is what we want. That's how much is in the account in the beginning. How much is in the account in the beginning? Remember, here we're making monthly withdrawals, right? So here, both of these are going to be 12. In other words, the account is also being compounded monthly. That's another reason why they're both equal to 12. So if you do that in the TVM Solver, let me show you. Okay. So what do we get? FV, right? Okay, so capital N we said was 300. There, wrong button. So we have 12 times 25. Oh, wrong button again. I we said is 6. Okay. Again, you don't have to type the percent sign, you just type the number. PV is what we're looking for. PMT is 1,500. FV, right? That's how much is going to be in the account after this is over, after 25 years. Well, again, we're taking money out. This is a retirement account. We're retiring. So theoretically, we want nothing left in the account after all this is done. So FV is 0. And these two we set as 12. There we go. We're solving for PV. Click. Okay. Again, this is negative because it's in the account away from us. So negative 232,810.3. And I think that's what we have on the slide. Good. So let me stop. So any questions on this stuff? Okay. Stop. Okay, here we go. So that's what we get here. Okay. All right, so here, this was another question, okay? Thought I took out B and C here, but that's okay. All right, anyway, so here we want to be able to withdraw. This is $30,000 each year for 25 years. Okay, this is each year for 25 years. And the account is earning 8% interest. I don't want to do parts B and C though. I mean, B we could actually complete. Part C though, I don't want to do. Okay. So we want to be able to take out $30,000 each year for 25 years. And the account is earning 8% interest. So we do have a payout annuity because there are multiple withdrawals. Okay. So we can use the formula. What we want to know here, how much we need in the account when we retire. How much do we need in there initially? So it's just like before, we want to know what P0 is in our formula. PMT, we know what that is. It's $30,000 each year. R is the annual interest rate. It's 0.08. N in this case is 1 because we're making annual withdrawals. So the account is being compounded once a year, annually. So N is 1. And this is going on for 25 years. Okay, and we'll go through the formula next time because let me see, unless I'm mistaken. Nope, we have like 5 seconds left. So, okay, so let me stop.